Hello and welcome back. Looks like we've got some linear equations we've got to work out here. It says determine the linear equation of each of the following graphs in the form y equals mx plus c. So our first graph is A. We can see our gradient seems to be going up from left to right. So first let's just write down the equation. Y equals mx plus c. Now, for that, let's use maybe green. C, that is our y-intercept. And if we have a graph, sometimes we can see immediately, my y-intercept, that's 8. So if I wanted to, maybe on the next line, I could just write C equals 8. Now, the next part of our equation that we've got to work out is m. Now, m, another word for that might be the slope of the line. Another way of describing it might be the gradient. And there is a formula for gradient. One way to think about it is rise over run. Another way to think about it might be the change in y, or delta y, over the change in x. And another way we could write this, there's a lot of ways to think about gradient, is y2 minus y1 all over x2 minus x1. So if we're thinking about it in this last form, we need two coordinates. So luckily, in our graph here, we have this coordinate here, which is very easy to see, and our y-intercept up there. So our first coordinate here would be -2, 0. And up here we would have 0, 8. So we could use those and calculate our gradient. We can just substitute those values in, and let's try that out now. So m equals y2 minus y1 over x2 minus x1. And this will equal, what is y2? So if this here is my second coordinate, this I could label as x2, and this over here would be y2. And my first coordinate would be x1, comma, oh, not x, y1. So our first value, y2, that's just 8, minus y1, which is 0, that's very nice and easy, x2, which is 0, minus x1, x1 is -2, so put a -2 in there. Then we can simplify this a little bit. 8 minus 0 is 8, and 0 minus -2, that will equal a +2, or just 2. And 8 divided by 2, we can work that out, is 4. Now, we're pretty much done. We know m, and we know c. So if we wanted to, we can just write, well, y equals 4x plus 8. That's it. Now, calculating m this way, this will always work as long as you've got two coordinates. But depending on how nice your graph is, we can think of the gradient as rise over run. So rise, that's how far up it goes. So here you can see, if we treated this like a little triangle, a little right angle triangle, how tall is this triangle? Well, it's 8 tall. And what's the run? How from left to right? That's just 2. So if we thought of it as rise over run, we could work it out as just 8 on 2, which is 4. And that is a much quicker and simpler method of calculating your gradient. But knowing it as y2 minus y1 over x2 minus x1 can be very useful in more complex questions. So now let's look at question 5b. So we'll write the equation again. Let's do it over here. 5b, y equals mx plus c. We can do the same thing as before. For our c value, which is our y-intercept, it's just here. So we know that c is going to equal -3, because that is where it intercepts the y-axis. And then if we want to calculate our gradient, let's try it. So How should we do this? Let's try the orange method. Just thinking of it as rise over run. So if we go from this coordinate and go across to the origin, and then go down to the y-intercept. So the rise, it's going down now. So our rise is going to be -3 over, and going across, that's just 2. So that's our gradient. We just got that from looking at the graph. So if we wanted to, we could just write down y equals -3 over 2x minus 3. Now we can do the gradient formula, the y2 minus y1 over x2 minus x1, and we will get the exact same thing. So make sure you choose whatever method is appropriate for you. That's all the time we've got for today. Thanks for joining me, and I will see you next time.